Hi students, this is AJ sir. Let's study 9th standard ICSE Math exercises 6B, C and D. In exercise 6B, cancel question 1, that's very easy. Let's do the second sum. Now this is elimination by equating coefficients method. The first equation is given in the standard form. So that's equation 1. The second equation has fractions involved. So let's get rid of the fractions by finding the LCM. 3 and 4 LCM is 12. So one way to do this is multiply the whole equation by 12. So the denominators disappear and we get this as the second equation. Now if you look at the first equation and the second equation, we will use the elimination by equating coefficients method. The coefficients of x and this x are 3 and 4 respectively, whereas the coefficients of y are -1 and 3 respectively. We would equate either of these pairs of coefficients. If I want to equate the coefficients of x, then I'll have to make them 12 by multiplying by 4 and 3 respectively. Instead, let me equate the coefficients of y. I have 3y here. So I would like to have 3y even here. I should have the coefficient, the same coefficient. There is a 3y here. I won't change anything in this equation. Rather, let me make this as 3y. How do I do that? Multiply this whole equation by 3. So when I multiply this whole equation by 3, I get 3x multiplied by 3, that is 9x, into 3, that is -3y, and into 3, that is 69. So I have changed equation 1 into a new equation by multiplying by 3. Why did I do that? Because now the coefficients are same. At this point, the sign could be plus plus or plus minus or minus plus. It doesn't matter, we can still solve. The first step is to equate the coefficient of either y or x. I chose y because I found that easier. Next, I would like to eliminate y. So let's add both these equations. This was equation 2 and this is the modified version of equation 1. If I add them, 4x plus 9x is 13x. 3y minus 3y gets eliminated. That was the whole aim of this method. And 48 plus 69 is 117. So you see, I get a new equation by adding the two equations. And in this new equation, there is no y. It's eliminated. Only x is left. So now I can find the value of x, which is 9. And next, once you find the value of 9, you can substitute that value in any of the equations, let's say out here, and then you can get the value of y. So this method can also give us the solution by eliminating the coefficient of any one variable. Now in the fourth sum, again two equations are given. The first equation has fractions and brackets, so let's simplify it and write it in the standard form. Cross multiply, 4 goes up, 5 goes up here. Open the brackets, distributive multiplication, variable terms on the left hand side, number on the right hand side. This is equation 1. Now the second equation is also given. If you look at the first equation and second equation, neither of the coefficients are matching. 4, 26, 5, 3. We can eliminate a variable only if the coefficients are same. So let's equate or equalize the coefficients. 4 and 26 LCM will be too big. So let me find the LCM of 5 and 3. That's 15. So what I'm going to do is I will multiply this whole equation by 3. So it will become into 3, into 3 and into 3. So when I multiply this whole equation by 3, I get this equation. 12x plus 15y is equal to 39. Equation 1 multiplied by 3. And the second equation, even this should become 15y. Just like I made this as 15y, let's make this also as 15y. So multiply the whole equation by 5. So the second equation is modified into 130x plus 15y is equal to minus 20. That is second equation multiplied by 5. Now that was the end of the first step. So in the first step, we have equated the coefficients of one of the variables. In this sum, I chose to equate the coefficients of y. Now we can eliminate them because the coefficients are same, so we can eliminate them. But here, since both of them have the same sign, plus and plus, I'll have to subtract the two equations. That is this equation minus this equation. If we would do it horizontally, there would be brackets here, bracket minus bracket, and whenever you subtract, the signs change. So it will be 12x minus 130x minus 130x, that's minus 118x. 15y minus 15y, this will be minus, so this gets eliminated. That's the whole aim of doing this method. And 39 minus minus 20, minus minus will become plus, so the sign changes here. Only when we do subtraction of the equations do the signs change. If it was already plus and minus or minus and plus, then I would have added the equation like we did in the previous sum. In that case, the signs won't change. So here 39 plus 20 is 59. So you see y has disappeared and now the only variable left is x. So get the value of x, which is minus 1 upon 2. Substitute this value in any of the equations. Let's substitute in equation number 1 out here. So instead of x, I will write minus 1 upon 2. Make sure you mention from equation 1. And we solve this and get the value of y. In the end, we should also write solution set x is equal to minus half, y is equal to 3. A final answer makes our presentation better. Now in the sixth sum, again, two equations are given. So we start with equation number 1. Open the brackets, cross multiply, get the equation. X and minus 12x goes here and becomes plus 12x, like terms together. 13x minus y is equal to 48 is equation number 1. This cannot be simplified further. Now let's start with the second equation. Second equation, open the brackets, like terms together. I get minus x plus y is equal to minus 12. Let's write this in the standard form. I don't like minus in the beginning, so change the signs of the entire equation. So it becomes x minus y is equal to 12. This is similar to just multiplying this entire equation by minus 1. So I got this second equation. Now if you see the first and the second equations, the coefficient of y is already same. It's 1 and 1. So it's already equal. So let's directly start eliminating it. Let me copy the first equation again out here just below the second equation. Or I could have written the first equation and second equation below that. It doesn't matter. Since the signs are same, I have to subtract the two equations from each other. So x minus 13x is minus 12x. Of course, the signs will change because there is a subtraction here. Minus y, minus minus becomes plus. So minus y plus y gets eliminated. That was obvious. 12 minus 48 becomes minus 36. So y is eliminated, only x is left, minus sign disappears, x is equal to 3. Now substitute this in any equation. I'm going to substitute this in equation 2 out here. So on substitution from 2, I get the value of y as minus 9. So that's the solution set. Now mark the 10th sum as IMP. This is a very unique sum. A typical sum, whenever you see that the coefficients are mirror images of each other, x 41 here but y is 41, y has coefficient 53 and here x has coefficient 53. So the method is that first we add both the equations so that we get 94x plus 94y is 282. And if you divide the whole equation by 94, we get x plus y is equal to 3. That is equation 1. And then we subtract these two equations. And this time we get minus 12x plus 12y is equal to minus 12. We divide the whole equation by minus 12. We get another equation, x minus y is equal to 1. So you see, using the two given equations, we have now derived two new equations which are much simpler to solve ahead. We can solve this by other methods, by equating coefficients, etc. But that would be very difficult because these numbers are huge. So this method is the simplest and perfect for such a sum. Now we got these two equations. The coefficients are already equal. Let me eliminate y because the signs are different. So I simply have to add the two new equations. So y gets eliminated here. And I get the value of x as 2. And then I can simply substitute this value of x in any equation. Let me substitute it in equation 1 out here so that I can get the value of y as 1. So that's the solution set. Now in the 12th sum, two equations are given and we have to find the value of these two expressions. So first we will solve the two equations simultaneously and get the values of x and y by the normal method. Equation 1 and equation 2, let me equate the coefficients of y. 10 and 18, LCM is 90. So let me multiply this whole equation by 9 and let me multiply this whole equation by 5. By doing that, I get two new equations. So this way, the coefficients of y are equal. We could have targeted x as well, but I have chosen y because the signs are opposite. So now I simply have to add it, and when you add it, it becomes easy. Just eliminate the y, add the x terms and the numbers, you get the value of x as 1 upon 3. Substitute this in any of the equations. I'm going to substitute it in equation 2 out here. So I should mention here from 2. And then solve algebraically to get the value of y. But the sum ain't over yet. After getting the values of x and y, now we have to find the value of the expression given in the question. Well, just substitute the value of x and y, solve, get the LCM and the answer. So that's the answer for the first expression. And similarly, substitute in the second expression and get the value of the second expression. You should convert this into a mixed fraction. Students, cancel the 7th sum and the 8th sum because they are easy and of the same type. So I want to reduce your homework. Mark the 18th sum as IMP. Now in 13.2, again, two equations are given. It seems a bit complicated, but we just have to remove the denominator by removing the LCM. Here the denominators can be removed by multiplying the whole equation by 8. So that is one method of making the equation simple. Just multiply the whole equation by 8. This way this denominator will disappear. Another method would be the LCM method, of course. So if I multiply the whole equation by 8, I get this equation. Remember to put the brackets here because there is a minus sign outside, and when the brackets will open, this sign will change to plus. This is a common mistake which students do, so avoid it and be alert about it. In the standard form, this is the final equation. Now, the second equation given is this. Again, multiply the whole equation by 3. That should get rid of the denominator. And we get the standard equation as 3x plus y is equal to 8. I'm giving it number 1. Or you could have given it 2 and call this as 1. I'm going to copy this equation once again out here. So that the two equations, two simple versions of the given equations are now one below the other. I see that the coefficients of y are already equal. That's good. Now, and the signs are also opposite, so I just have to add them. And if I add the two equations, y is eliminated, and on solving, I get the value of x. Substitute this in any equation. I'm going to do it in equation 1. So here I'm going to substitute the value of x as 4, so that on solving, I'll get the value of y as well. In the 15th sum, again, two equations are given, but there is a percentage written. Percentage simply means upon 100. So 10% is 10 upon 100 into x, and 20% is 20 upon 100 into y. Let's cut 0 and 0, and 0 and 0. So I've simplified it. I'm not going to reduce it further because I want the denominators to be same so that I can bring them together and shift it to the other side. So the simplified version of the equation is this one. Let's call it equation 1. Now the second equation is given as equation 2. I can't simplify this further, but I would like the coefficients of any one variable to be same. Let's focus on y. Let's make this 2y. How do we do that? Multiply the whole equation by 2. So that I got this new equation. I'm going to copy the first equation and the modified second equation one below the other. I can see that the coefficients of y are same. That is what I wanted, because now when I add the two equations, thankfully there is plus and minus sign, so I just have to eliminate it and get the value of x. Let's call it equation 3. Now substituting this value of x in either of the equations will give us a value of y. Let me substitute in equation 1. So on doing that, I got the value of y as 100. Now in the 16th sum, the two equations have not been given directly. This expression is equal to 3 and the values of x and y are given, so we'll have to substitute them. And the same expression is equal to 8 when the values of x and y are different. So let's put that in the form of an equation. So in the first case, this expression is equal to 3 when x is 5 and y is 6. So I get the first equation. And in the second case, the value of the same expression is equal to 8, but this time the values of x and y to be substituted are different, and I get the second equation. Interestingly, I again see mirror images, so I can do the method used in sum number 10, but since the numbers are small, I'm going to use the equating the coefficients method directly. So I'm going to focus on n. Let's make the coefficients of n equal. 6 and 5, LCM is 30. So multiply the first equation by 5 and the second equation by 6. I get two new equations such that the n's coefficient is same. Signs are same, so I'll have to subtract it. So 25 minus 36 is minus 11m. Minus 30 minus plus 30, of course it will get eliminated. And 15 minus 48 will give you minus 33. Minus gone. M's value is 3. That is equation 3. Now copy the equation number 1 once again. We could have used equation 2 also. Substitute the value of m from here. That is from equation 3. So solve and get the value of n. That's the solution set. Now the 18th sum. Two equations are given. The only reason why this is IMP is because the equation seems to be a bit complicated. There are fractions involved, but the method is the same. First we get rid of the denominators. The LCM of 5 and 4 is 20, so into 4 into 4 into 5 into 5. Now there is a minus out there, so make sure that you use brackets because this will remind you that this sign is going to change in the next step. The common denominator will shift to the RHS. Like terms together, simplify it and you get the final equation. We can't reduce it any further. Can we divide it by anything? No. Now the second equation as given, same method. The LCM in 6 and 2 is 6, so into 3 into 3. Get the numerators together, common denominator shifts. Like terms together and we get the second equation. Now we'd like to eliminate one of the variables. If you look at 1 and 2, I think it will be easier to equalize the coefficients of y. 15 and 55 What's the LCM of 15 and 55? If you don't know how to find the LCM, let me just show you. 15, 55. You can do this in the rough work. 3 5s are... No, this one go with 5. So let me start with some common factor. 5 3s are, 5 11s are. And now the uncommon factors. 3 1s are, 11 1s are. So 5 into 3 into 11 is 165. That means I would like the y coefficients to become 165. For that, I will have to multiply this whole equation by 3 and this whole equation by 11. So by doing that, I'm able to ensure that the y coefficients are same, but the signs are also same, so I'll have to subtract the two equations. Make sure you write all these reasons. So 18 minus 374 is minus 356. Y gets eliminated. It's 165 minus 165. 384 minus 1452 is 1068. Minus minus gone. And 356 goes down, and I get the answer of x as 3. Mark this as equation 3. Now substituting this in equation 1, let's say, out here, we solve this and we get the value of y. So that's the final solution.